We are back to the assertions now. Whenever we are writing a test case, ultimately we will have an output that will be matched against an expectation, and that is going to decide if the test case is a success or a failure. So ultimately, to do that, we need assertions. Without it, we cannot check or validate anything. JUnit provides many assertions, and those assertions are there in this class assertions. If we go to this class, we see lots of methods are there: assertTrue, assertFalse, and we will be uh, using some of them in upcoming lessons. All right. We already saw how to use assertEquals. So in assertEquals, we give two things. One is the expected value. The second one is the output, and then assertEquals will check if these two values are equal. If equal, then it's fine. The test case is a success. If not, then it's a failure. If we run this test case, we see the output matches with the expectation. So this test case is a success. But for some reason, if we change the expectation now so that they don't match, in that case, we'll see a failure. So we see that expected was H JUnit5, but the actual output was high JUnit5. So there is a mismatch. Now there is one more thing in assertEquals that I wanted to cover, and that is, in such cases, we can provide a supplier a message using a supplier. So let's say if the test case is a failure, if the expectation doesn't match with the output, then we want to show something, some message on the console. Then we can use this supplier to supply a message that there is something wrong or something like that. We will simply say something went wrong. If we run the test now, we see the message that we passed along with the actual error. So we can pass a supplier. The good thing with the supplier is, if the expectation matches with the output, then this string will not be initialized. It will not be created because we are using the lambda expression. We are providing a supplier. So that will be initiated in a lazy manner. So if the test case is a success, then this thing will not be evaluated, will not be executed, and it will not create a new string object. But this will be executed only if the test case fails, only if there is a mismatch between expectation and the output, same as with this case. Because we see an error, only then this string will be created, this supplier will return a message. So that is to basically save some memory, because what generally happens, we provide many messages in JUnit4, for example, and all those string objects are created in an eager manner. So whether or not that string message is required, the string object will still be created. That we can suppress using a supplier. Okay. In this video, we will see another assert method that we will be using to test the Boolean conditions. So we have the method in the main class, or in the greeter class status. It returns a Boolean. In this case, we are simply returning true, but in a real life code, we may have some logic, and that method may return a Boolean condition based on that logic. But from the example perspective, we are simply focusing on the return value, and we will learn how to validate a Boolean value in the JUnit test case. So I have added a new test method, and we annotated it with the @test annotation. Then we provided a meaningful description. Now, this is another example of a description. For example, we can provide a message in this way: given xxx means given some condition, some assumption, the status, in this case, the status is basically the method name. The status should return true. So this is again an example of the description that you can use when you are writing the JUnit test case that clearly defines what are the preconditions and what are the expectations. Okay. So this is the test class. Then we created a new object of the greeter and we called the status method and stored the output, the Boolean output in a variable. Now the thing is, how do we validate? How do we validate the output with an expectation? So we use the assertions class because all the assertions are there in this class. We use the assertions class. Then we see assert true. So here we see assert true is a method. Similarly, assert false is a method that can be used to test the Boolean conditions. As the name suggests, assert true will check if the output that we are passing to this method is basically true. Okay, if the output is true or the value that we are passing to this method is true, then the test case will succeed because the condition is that it will check that the passed value is true. And because the test case that we are writing, it says that we are testing the true condition, this should return true. So we can simply use assert true. It accepts a value. So we will pass that output to this value. And now if this output is true, then the test case will succeed. If for some reason it is false, then in that case it should fail. Okay. So for the time being, okay, let me simply run the whole test class or maybe just this test case. So you see, with the help of the IDE, we can simply run a single test case, not the whole test class. To do that, we simply need to click this button, this icon, and run the test method. So we see that this test case succeeded. It's basically green. But what if someone made a code change and in this condition, this method is now returning false, but the test case is saying that the output should be true. Now there is a mismatch between the expectation and the output. So this time if we run the test case, we should see a failure. And that's what we see, that expected was true because we are using assert true, but the actual value returned from the method was false. So this will fail the test case. All right. That's how we use assert true. Similarly, we can use assert false. For example, if we have another test, let me copy the same thing. Given xxx, status should return false. Let's say we have another test case to test the false condition as well. Test false. And this time, if we simply run the false one, then we see, oh sorry, I need to change this also, assert false. This time it's a success because what we are checking is that the output should be false, which it is in this case. So we can use assert true and assert false accordingly, depending on the condition that we are covering. So let me remove this one and let me change it to true again. Now, if you see in assert true, there are different versions of the assert true. One accepts the Boolean condition, second accepts the Boolean supplier. So what is this Boolean supplier? We can simply pass a lambda Boolean supplier, and then we can maybe call some method from this supplier to actually return a Boolean value. All right. So if we convert it to a lambda, we can say that greeter.status. Okay, so that is the purpose of Boolean supplier. Let's check other versions of assert true also, and the same applies with assert false. So we are only going to cover assert true. If we see Boolean supplier and then the second argument is a supplier of string, then we have other versions, Boolean condition supplier, Boolean condition string message. So let's use this one. output, and then a string supplier same as this one. So we can pass a message condition doesn't match. If we run this test case now, we won't see this message on the console because right now the test case is passing, and we know that with the help of lambda it will be evaluated in a lazy manner, and the new string object will be created, and this supplier will be called only if the test case fails to save the memory. So to test that, if we change the condition back to false again to test the to fail the test case and run the test case again, now we see the message on the console condition doesn't match, and we see the error that expected was true due to the assert true, but the actual was false. So the logic of this supplier remains the same for all the test cases to load the string object or to create the string object lazily. That is same for all the assert methods, whether it is assertEquals or assertTrue. But the topic of this video was to use or to test Boolean conditions using assertTrue and assertFalse. All right. Moving on to another assertion, consider this example. In this example, we have a names method in the greeter class, which basically returns an array. In this case, the type of the array is string. Now, think about it. If we have to validate an array, whether it is string or integer or of any type, how would we do it? One way could be to iterate the array, and then in each iteration, we will simply call assertEquals to identify or to validate the individual elements. So that is one way. And if we simply write this code, so we can do something like this: for string name and greeter.names, we do something like this: assertion dot assert equals. But now there is one thing, we need to know the order of the values, because we have to provide the expectation. Actual value we can get from this one, for example, like this. So now you understand the problem. Even if we are going with assert equals, how do we provide the correct expectation in each iteration? Now this is a hacky way. We can do something like this: expectations, and maybe some values here, hi and hello, and then we'll have to initialize an index so that we can get the values from the expectations, count plus plus, something like this. So you get the idea. It is difficult to validate the array. There is a neat way that is provided in the JUnit5 API. What we can do, we go to the assertions class and we call the method assertArrayEquals. Okay, it expects an array with the expectations and then the actual array. All right, so first let's pass the actual values. So we say greeter dot names, and then we have to pass the expectations. So we say, for example, new string hi and hello. Now the whole iteration thing will be done by the framework. If we run this test method now, we see it passed successfully. So what it did, it got the output, the return value from the names method, a string array. Then we passed the expectation in the form of the array in the same order of the elements. So we are passing the an array basically here. Then we are calling assertArrayEquals. What it will do, it will simplify the whole validation process. It will take care of the iteration and everything. Finally, it will validate each and every element of the expectation array with the actual output. That's how we use assertArrayEquals in case we have to validate the arrays. All right. Before we move on, I wanted to cover one more thing. So we have already talked about the lifecycle methods, but where do we use it? So here is one use case where we can use the lifecycle methods. Let's revisit this whole test class. If you see the test cases, you will see a repetition. You see we are creating the new object in each test method, greeter equals to new greeter. And this repetition is going on in each test method. Can we simplify it? If we think about it, we have to do it for each test case, and we know that there is something provided in the JUnit5 API that can do the same thing for each test method. You guessed it right, we can do it using the before each lifecycle hook. So what we can do, we can create a before each method, because we have to do this thing before each test method. Okay, so we say init greeter. It's up to us how we name it. The main idea is to use the before each. Then, for example, we initialize the greeter. What we can do in the before each method, we can say that create a new object of the greeter. And then we can remove this line from all the test cases. We don't need it anymore. So let me remove it. And similarly from this method. So what we are saying, we are using before each lifecycle method, we are saying that before executing the test case, please create a new object of the greeter class. And that new object will be used by the test case. This is a class level variable, an instance variable, so it can be shared or it can be used by all the methods. The important thing is we are reinitializing it before running a test case. That is the purpose of before each, right? Now, if we run this whole class, we should see no impact on the existing test cases. Okay, so we see that because we changed the expectation, so it is failing, which is as per the expectation. This one, if you see, we are using assertTrue, but the status method is returning false. So this is also failing as per the expectation. Test names is passing because we are simply validating the names array with the same expectation. All right, but the important thing that we did in this tutorial, that we moved the repetition to the before each, and in such cases we can use lifecycle methods. All right, the next set of tests is to validate the null values. We can check if the return value is null or not. Consider this example. I have added a new method in the greet class, the name find by id. It accepts an integer parameter and it basically checks if id is 1, then return a string value found. If not equals to 1, anything else, just return null. So the return type is string. Now this is a very simple test case or simple method. There is nothing fancy about it. We just need to basically cover the null cases. All right, so you get the idea. You may have a similar function in your code base and you may need to check if the return value is null or not. So we'll see how to check that. We'll start with a new test method, public void test find by id. Okay, we already have access to this greeter object, so we can say string output equals to greeter dot find by id, and let's pass it 1 for now. So we know that if we pass 1, we will get a valid string which is found. It's not null. And because this is the expectation, we should say that if we are passing the id 1, the return value should not be null. Maybe we are not interested in the actual value. We simply want to test whether it is null or not. To do that, we will use assertions and assert not null. So it takes a value and it checks whether or not it's null. If this is not null, then the test case would pass. So we are checking not null condition. In this case, because we are passing 1, that would return the value found and which is not null. So we see that the test is a success. Assert not null. But what if we pass something else? So let's do that as well. In the same method, we can say null output equals to greater dot find by id 2. In this case, we know because it's not 1, so we will get a null in the output. And if we use the same method, assert not null, null output, so we should see a failure. Here it is. Because although this condition was successful, but for this condition, the value that we passed is null, but we are saying assert not null. So that would fail. To fix that, we know that in this case, we should expect a null value. What we can do, we can use another method which says assert null. It means we are expecting a null value. Now, if we run the test case, we see it succeeded successfully. So that's how we use assert not null and assert null to test the null values. Okay, moving on. I have cleaned this class. There is only a single method now, find by ID, and so a single test case. I've removed everything so that we can focus on the example. Now in this method, we added a new condition for the ID that if ID is less than 0, then throw an illegal argument exception that with a message ID must be a positive integer. So that is the only change in the find by ID method. Now in the test case, we are already checking the not null and null assertions by passing the ID 1, in which case it will return found. But if we pass any other value, let's say 2, then it will return null. So we are checking assert null and assert not null. Now since we added a new condition for negative numbers, we know that if we pass a negative number now, we get an exception. Now how do we validate it? How do we write a test case to cover this condition that if we pass an input, negative input, then it should throw an exception, and with this message ID must be a positive number. So let's do that. In assertions class, we have methods to check the exceptions. First of all, we'll see there is one that says assert does not throw. It simply checks that the method that we pass to this method is not throwing any exception. It does not check a particular exception, but any exception. So it's kind of a wildcard check that whatever method we are calling as part of assert does not throw, it does not throw any exception at all. So let's try to use that. First of all, assert does not throw. It takes an executable. Let's see what this executable is. So if we create an anonymous inner class of new executable, then we know that, okay, it seems to be a functional interface. Yes, it's a functional interface executable which has a single method execute. And we know that if we have a functional interface, we can pass a lambda. Now, what we need to do is we call the code from the execute method. So something like this, greater dot find by ID, and let's say we call 1. Sorry, we pass 1. So that is the implementation of the executable, and since this is a functional interface, we can change it to the lambda. So let's do that. Replace with lambda. That's it. So when it runs, it will check that this method call does not throw any exception, and we know that because if we pass the parameter 1 input 1, we get a finite string in the response without any exception. If we run this test case now, we see it succeeded. Okay, so we checked that it does not throw any exception. Next thing is to check when it throws an exception. To do that, we use another method, assertions.assertThrows. So here we see we have bunch of variants for assertThrows. This expects an exception class, a class type of an exception that we are expecting, then the executable and a string message if there is a mismatch. Similarly, this expects the class type of the exception and the executable, and this with a supplier of message. So we can use this one. We know how to pass the message and how to pass the message using supplier. We already know that. So the first argument is the expected type, and if we see, this basically is, let's go to this. So this is basically expected type, a class of expected type. So the first parameter is what kind of exception are we expecting. So in this case, we are saying that if we pass a negative number, we should see illegal argument exception. So that's what we are going to provide here, the class type. All right. The second argument is the executable, which holds the method calling code, which is same as this one. So we simply copy it. That's it. Now let's call this method with this code. So we see it failed. It failed because for this assertion, we are saying that if we call this method, it should throw illegal argument exception, but we passed the input 1, which does not throw exception. So that's why this assertion failed and the whole test class also failed. Okay, so we need to pass an input that will throw this exception so that we cover the correct condition, and that condition is for the negative number. So if we simply pass a negative number, in that case we see it passed successfully, because when we passed the negative number, we know that it will throw a new illegal argument exception, and this type and this type is a match, so the test case is a success. Okay, now we can do something else also with the assertThrows. If we check, the return type of assertThrows is a class that extends throwable. So that means we can capture the exception thrown. We can also check the message of the exception, this message. Let's try to do that. Exception thrown. And we can say assertions dot assert equals exception thrown dot get message. We are checking that first it will throw the exception, then the message of this exception should be this. And we see it succeeded. So we learned how to validate the exceptions, how to validate that the code is throwing or not throwing an exception. This is how we check that it does not throw any exception. And with assertThrows and passing an exception, we check that this method call or whatever method call we are providing will throw this kind of exception. Additionally, we can check the exception message as well. All right. Okay, moving on. So in this test case, we see that we are testing multiple conditions, 2 related to null values, then 3 related to exceptions. So we know this test case, this JUnit test case is testing these conditions as a unit, a kind of a unit, which is related to this method. Now there is another way to do the same thing using assertAll. So if we have bunch of conditions and we want to test them as a single unit, we can use assertAll that simply says that validate all the conditions that I'm providing as a unit. Okay. So we say assertions dot assert all, and it accepts, it has many versions. So it, for example, it says that string heading, which means we can provide a string value, a heading, a description. Then important thing is it accepts executable, vararg, a collection of executables, stream of executables, which basically means we can pass multiple executables. We already know what is an executable. It is simply a way to call or to provide basically the method calls, the code that we are testing. So let's pass a heading find by id test, and then we'll pass the executable. Okay, so this is the heading and this is the executable. All we need to do is we need to move these conditions inside the executable. That's it. Now we are saying that you need to assert all these conditions. If we run this code, we see that it succeeded because all the conditions are valid conditions and their expectations are matching. Okay, so that's how we club multiple assertions and we group them as a single unit. In that case, we can call assert all. Okay.